Hello everyone, this is Dan, and we are continuing with our function transformation topic, and this will be our last video on this, and we are exploring transforming exponential functions. So the form of a typical exponential function is f of x equals a times b to the x plus p, all plus q. And our comparison equation, or our baseline equation that we're going to be looking at, is f of x equals b of x. So if we look at some of the transformations, we're looking at q first. Q, just like in our linear, quadratic, and hyperbolic function, is responsible for the vertical shift. And if it's positive, we're going to be moving upward by q units, and if it's negative, we're going to be moving down by q units. And remember that our horizontal asymptote is going to be represented by y equals q. So our a will determine if our graph is increasing or decreasing, and most importantly, if it's above or below the x-axis. So if it's positive, it's going to be above the x-axis and increasing, and if it's negative, it's going to be below the x-axis and decreasing. And the increasing or decreasing bit will change slightly depending on b, so we'll have to take a look at that together in a little bit. So here, all we have is in front of our 2 to the x, we're assuming our a is 1 and positive, so this is increasing and above the x-axis. On the right, we have f of x equals negative 2 to the x, so our a is negative, so we see the graph is below the x-axis and decreasing. So now what happens about b? So b will determine if our graph is increasing or decreasing, and this is going to be assuming that a is greater than 0. So if our b is greater than 1, our function will increase. If our b is between 0 and 1, our function will decrease, and then it's just not defined if it's negative. So here we can see on the left side our b is greater than 1, and so we increase, and on the right side we have 0.2 for our b, so we are decreasing. Now if we put the effects of a and b all together, we can see with our a's, they are going from negative to positive, negative to positive. So our red, because it's negative, is below the x-axis. The green and the black are both positive, so they'll be above the x-axis. And our purple again is negative, so it's below the x-axis. And then if we look at our b's, we can see with the red and the green that they're 0.2. So for the green function, we actually have an a that's greater than 1, so we can see that that's decreasing just like it should. And with our black, we can see that our a is greater than 1, so it's increasing just like it should. So if we look at our form, again, just for a recap, or now we're looking at the effect of p, we can see that our p is responsible for a horizontal shift. So if it's positive, it'll move to the left by p units, and if it's negative, it'll move to the right by p units. So here we have 2 to the x plus 2. So as you can see, our entire graph shifted to the left by 2 units, and on the right we have f of x equals 2 to the x minus 2, so our entire thing shifted to the right by 2 units. So you can see this goes over there, and this one goes over there. So let's try an example problem together. Transform the baseline function down by 5 units. So in order to do this, we know that we need to change our q. And if we're going down, we need to do minus 5. So we have f of x equals b to the x minus 5. And this will transform our function so that it shifts downward by 5 units. So let's try another one. Transform the baseline function so it goes to the left by 2 units. So left or right is horizontal shift, so this would be our p. And remember that in order to move left, we have to add 2 for our p. So here it would be f of x equals b to the x plus 2. And that's how you can transform it so it shifts to the left by 2 units. If you guys have any questions, don't hesitate to ask us in the Ask a Tutor function or in our live lessons, and I will catch you guys next time. Bye!